Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Salamat! Ang pag-usapan natin about power system at we will review some uh, things about three-phase system. So let's define first what electrical power system is. It is a network which consists generation, transmission, and distribution system. It uses different energy sources, whether it is conventional or non-conventional, and converts it into electrical energy. The power system includes electrical equipment and devices connected to the system, like the synchronous generators, transformers, conductors, circuit breakers, motors, and others. Here is the list of the components of power system: the generation, transmission, distribution, and consumption. The distribution is responsible on how power is produced or created, while the transmission, it is responsible on how power is moved from one point to another. Distribution is responsible on what power level is assigned to different end users. Consumption refers to those who will use the demand power. So as we can see in our image, again, this is the list of the major components of our power systems. We have the generation facilities. So ibig sabihin yung ating mga power plant na nagki-create ng ating power, no? Whether they are conventional or non-conventional. When we say non-conventional, ito yung mga renewable energies natin. At yung mga conventional natin, yung hydro or diesel power plant. Okay? Then we have also the transmission line. As na-define na natin kanina, the transmission line is responsible in moving the power from one point to another. And we have also the distribution line going to our consumer loads. So meron din tayong mga electrical symbols ginagamit sa pag-design ng power system. We have the generators, transformers, transmission line. We have the oil circuit breaker, the air circuit breaker, the bus, delta connection, Y connection, the grounded Y connection, motors, and circuit breaker, which is draw out type. So let's have here a pictorial diagram of a power system. As we can see from generating station, then we have here the transmission substation, transmission lines, transmission substation again. Then we have here the distribution part from industrial to commercial and residential customers. Itong power system natin na pictorial diagram ay pwede nating i-design using yung electrical symbols na in-introduce natin kanina. So from power system na pictorial diagram, pwede natin siyang gawa ng single line diagram. So as we can see, yung generating station, pwede natin siyang i-represent using the symbol of generator. Yung transmission substation natin, of course, we have here the transformer and the breakers. And we have also the bus, as we can see, yung vertical line. Then yung mga horizontal lines natin, transmission line, transmission line. Then we have here the distribution transformer and the distribution line going to customer loads. So let's have a review of three-phase system. So yung three-phase voltage sources natin, pwede natin siyang i-consider o i-categorize sa dalawa. Pwedeng ang maging source natin ay Y-connected source or delta-connected source. Ganun din yung ating mga three-phase loads. Pwede rin maging Y, pwede rin siyang maging delta ang ating mga loads. So, ibig sabihin, pwede tayong magkaroon ng 4 3-phase source load configuration. YY, Y delta, delta delta, delta Y. Sa YY, ibig sabihin, Y ang ating load, Y ang ating source, Y din ang ating source. Y source, Y load. Y delta, Y ang source, delta ang load. Delta delta, delta ang source, delta ang load. Delta Y, it means the source is delta and the load is Y. Here is an example of a YY connection. So we have here a Y source and Y load. When it comes to Y delta, we have Y source and the load is delta connected. Delta source and delta load. Delta source and Y load. So let's study kung ano ang current and voltage when it comes to Y connection. The current in any line is the same as the current in the corresponding phase, meaning the line current is equals to phase current. While the line voltage for a Y-connected system is square root of 3 times its phase voltage. So, kung i-equate natin yan, gagawin natin ng equation, the line voltage is equals to square root of 3 multiplied by the phase voltage angle 30 degrees. So again, so the line voltages are shifted by 30 degrees with respect to phase voltage. Kaya since leading ang ating mga line voltages, naiiwan ng 30 degrees yung ating phase voltage. Kaya magdadagdag tayo ng plus 30 degrees. It means in a connection with ABC sequence, the line voltage leads the phase voltage. So, in delta connection, the line voltage in delta connection is equal to the phase voltage. And the line current for a delta connected system is square root of 3 times its phase current. The line currents are 30 degrees behind the respective phase currents. So, ang equation natin, the line current is equals to square root of 3 multiplied by the phase current angle negative 30 degrees. When it comes to power, we have two equations for power in Y connection. So we have here P is equals to 3, ang ating multiplier. Then we use the phase voltage and the phase current multiplied by the cosine theta. The power can also be represented by square root of 3, ang multiplier natin, multiply by the line voltage, multiply by line current, multiply by cosine theta. So remember that cosine theta is equals to power factor. So meaning, yung ating mga equations ay pwede nating sabihin na power is equals to 3 multiplied by phase voltage multiplied by phase current multiplied by the power factor. The same thing, power is also equals to square root of 3 multiplied by the line voltage multiplied by the line current then multiply by the power factor. So as you can see, whether we use delta or Y, we derive the same formula for power. So power is equals to 3 multiplied by the phase voltage, phase current, and cosine theta. On the other hand, if you're going to use the line voltages, that will be equals to square root of 3 multiplied by the line voltage, multiplied by the line current, multiplied by cosine theta. Since cosine theta is equals to power factor, then we can say, katulad nung ginawa natin kanina, ang multiplier na natin ay power factor. So phase quantities in each phase of a Y or delta connection, yung real power natin, P is equals to 3 multiplied by phase voltage multiplied by phase current multiplied by cosine theta. That is our real power. So yung real power natin, tinatawag din natin siyang true power at active power. So reactive power is represented by Q. Ang ating equation is 3, phase voltage, phase current, then sine theta. While the apparent power is equals to 3 multiplied by phase voltage multiplied by phase current. While the reactive power can be represented by this equation, Q is equals to square root of 3 multiplied by the voltage line multiplied by the line current times sine theta. The apparent power is equals to S is equals to square root of 3 multiplied by the line voltage then multiplied by the line current. When we say balanced system, all three phase voltages are equal in magnitude. All phase voltages are in phase by each other. That is 360 degrees divided by 3 is equals to 120 degrees. All three phase currents are equal in magnitude. All phase currents are in phase by each other, meaning they are separated by 120 degrees equally. A system in which the loads connected across three phases are identical. So yun ang ibig sabihin ng balance. So let's have a practice problem in three-phase. So a balanced load of phase impedance 100 ohms and power factor of 0.8 is connected A in star, B in delta to a 400 volts three-phase supply. Calculate the power dissipation in each case. So in problem number 1, so we have the following given. The phase impedance is equals to 100 ohms. The power factor is equals to 0.8. The line voltage is equals to 400 volts. We are asked to solve for the power when these given are connected in Y, and letter B, the same requirements. We are asked to solve for the power when the given are connected in delta. So let us solve first the phase voltage. So the phase voltage is equals to line voltage divided by square root of 3. So that is 400 over square root of 3. And we will get 231 volts. So to solve for the phase current, which is also equals to the line current, since this is Y, that is equals to phase voltage divided by the phase impedance. So 231 volts divided by 100 ohms, we will get 2.31 ampere for the line current. Now we're going to solve the power using the equation square root of 3 multiplied by the line voltage multiplied by the line current, then cosine theta or cosine P. So substitute all the given values, then we will get power is equals to 1.28 kilowatts for the power. So that is our answer when the circuit is connected in Y. So in letter B, we are asked to solve when the given are connected in delta. So we all know that in delta, the phase voltage is also equals to line voltage. So that is equals to 400 volts. So we can get the phase current, that is phase voltage divided by the phase impedance. So that is 400 divided by 100, and we will get 4 amperes for the phase current. But we all know that the line current is equals to square root of 3 multiplied by the phase current. So that is equals to square root of 3 multiplied by 4. So we will get 6.93 amperes. So using this value and substituting to our equation, we will get the power is equals to 3.84 kilowatts. So as we notice that this power in delta is 3 times more than the power in Y. So we can say that the power in delta is equals to 3 multiplied by the power of the Y. So let's have problem number 2. So a balanced star-connected load is fed from a 400 volts, 50 hertz, three-phase supply. The resistance in each phase of the load is 10 ohms and the load draws a total power of 15 kilowatts. Calculate A, line current, B, power factor, C, load inductance. So let us have the following given. The phase resistance is equals to 10 ohms. Power is 15 kilowatts. The line voltage is equals to 400 volts. And the frequency is 50 hertz. And we are asked to solve for the line current, the power factor, and the load inductance. So to solve for the line current, the power in one phase will be 1/3 of the total power. So 15,000 divided by 3, that is 5 kilowatts. So since power is equals to I squared R, so we can solve for the value of the line current, which is also equals to phase current, that is the square root of P over R. So that is 5,000 divided by 10. So we get the value of the line current, which is equals to 22.36 amperes. So for the power factor, so we will use our equation for the power. So konting manipulation lang to solve for the power. So alam natin, we can equate that into power factor. So substitute our value, that is 15,000 divided by square root of 3 multiplied by 400 multiplied by 22.36 of line current. Then our power factor is equals to 0.97. For letter C, to solve for the load inductance, using our theta and the power factor, that is cosine, our cosine 0.97, and we will get 14.07 degrees. So tangent theta is equals to X over R, or the reactance over resistance. So nakuha natin itong equation na to using the impedance triangle, yung principle ng SOHCAHTOA. So since tangent is opposite over adjacent, so alam natin ang opposite side dito sa ating impedance triangle is the reactance at ang ating adjacent side is the resistance. So tangent theta is equals to X over R. So to get the value of X, or the reactance, that will be equals to R tangent theta, and substitute this value to get the value of reactance, that will be equals to 2.51, or simply the value of R is 10 times tangent 14.07. So solving for the value of the inductance is simply L is equals to X sub L over 2 pi F. So X sub L is equals to 2.51 divided by 2 pi multiplied by 50, and we will get the value of the inductance as 8 millihenry. So for problem number 3, a balanced delta connected load takes a phase current of 15 amperes at a power factor of 0.7 when connected to a 115 volts 50 hertz three-phase supply. So calculate the power drawn from the supply, and letter B, the resistance in each phase load. So the following given, yung phase current natin is 15 amperes. Power factor is 0.7. The line voltage is 115 volts. And the frequency is 50 hertz. And we are asked to solve for the power and the phase resistance. So let us solve first the line current. So line current is equals to square root of 3 multiplied by the phase current. So that is square root of 3 multiplied by 15. So that is equals to 25.98 amperes. So then we will solve for the power. So that is square root of 3 multiplied by the line voltage, which is 115, multiplied by the line current, and multiplied by the power factor. So that is equals to 3,622.5 watts. Or simply 3.62 kilowatts. So for the base power, that is simply, we will divide the power by 3, and we will get 1,207.5 watts. And solving for the resistance per phase, so that is power per phase divided by phase current to be squared. So that is 1,207.5 divided by 15 squared at the phase current. So our phase resistance is equals to 5.37 ohms. So that's all mga ka-wisdom. Again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Thank you at kita-kits sa next wisdom video.